So here's the first of one or two or three videos of factoring review. So the first thing you look for when factoring a polynomial is always a greatest common factor. Um, so for this one, and now it doesn't have to be the first thing you factor out, greatest common factor, but it definitely is the easiest way to do it. Um, and I'll show you an example of that in a video to come. Anyhow, if you look at this polynomial down here, you look at all the coefficients, the 3, 18, 24, and 30, and they obviously have a common factor of 3. So we're going to factor that out. And for the variables, just look at all the variables. They all have x's, and choose the common factor would be the one with the smallest exponent. So 3x squared is a common factor. And the other factor associated with it is whatever would fill in these 1, 2, 3, 4 blanks that would make these four monomials when you multiply 3x squared by them. In other words, 3x squared times what is 3x to the 10th? And the answer there is x to the 8th. So all factoring is undoing multiplication. So 3x squared times what is 18x to the 7th, well, 3 times 6, and x squared times x to the 5th. So we're just making sure that whatever we multiply out, if we multiply it back in, we're going to start with the same thing. We're going to get the same thing we started with. So 3 times 24 is 8, x squared times x is x cubed, and 3 times 10 is 30, and x squared times 1 is x squared. So there you go. Basically, it's a reverse distribution. Distributing is multiplying, and factoring out a common factor is just undoing that multiplication. So the best way to check is just to distribute this in and make sure you get what we started with. Now, there are little other ways to think about that. When you factor out the 3, to figure out what coefficient is left, you just divide each of these coefficients by 3. And then for the x's, you just subtract from their exponent whatever exponent you factored out. So that's the other way to think about it. Be careful when looking for a GCF, or be careful to look for a GCF. For example, if you have this. Now, this one is easy to say, well, I'm just going to do my A times C method, 4 times 12, and so on and so on and so on, and get a factoring that looks like this, if it factors at all. But that complicates things. It's easier to first look for a GCF if it has one, and this does, and factor it out. Because if you are going to then factor this remaining quadratic, it's going to be a lot easier to do than if they all had the factors of 4 in it. So now you could just look for factors of 3 that add up to -2, which I don't believe there are any, so you'd be done factoring here. The next video is going to go over factoring quadratics like this. So stay tuned.